This is a question from GATE 2022, and the question is the current I in the circuit shown is dash. Okay, so there is a network here, circuit here with two sources, one voltage source and one current source, and we need to find what is this current. Okay, so since there are two sources, we can apply superposition theorem. Okay, so first I will apply superposition by finding the current I due to this source, voltage source, then the current due to the current source, and I will add both. Okay, so first I'll take the voltage source. Okay, so in superposition, when I consider one source, the other source should be removed, right, or replaced with its internal resistance. So here first I will consider the voltage source, so I have to replace or the current source using its internal resistance. So I have to open circuit the current source. Okay, so this is 2k, this is 2k, and this is 2k, and this is the current. So I'll call this as due to the current source, voltage source, so I'll call the current I as I1. Okay, so from this circuit, what is this I1? The current I1 is this current, right, because this current is 0 ampere. So I1 is equal to the net voltage 5 by the net resistance 2k plus 2k, right? So this is 5 by 4k, or this is equal to 1.25 milliampere. Okay, similarly, so this is due to source 1, and I'll have the next source 2. So here I need to find the current I due to the current source 1 milliampere, right? So this is 1 milli. So here the voltage source should be short circuited, and this is 2k, 2k, 2k. Okay, so here due to this current source, the current will be like this, I2, but the current I need to find is I in this direction, right? So I can call this minus current. Okay, anyway, in the circuit, what is this I2? So I can find I2 by current division method, right? So I have 1 milliampere here, so this current I2 will be equal to 1 milli into the opposite resistance, that is 2k by sum of two resistance 2k plus 2k. So 1 milli by 4k into 2k, so k cancelled 2, right? So it is 0.5 milliampere. So what is the net current I1 actually plus I2, but this I2 is actually opposite, right? So I1 minus I2, I1 is in this direction and I2 is in the opposite direction. So net current is I1 minus I2. So 1.25 milli minus 0.5 milli, so this is equal to 0.75 milliampere, right? Milli is 10 power minus 3. So answer is B. This is the next question again from GATE 2022. The question is consider the circuit shown in the figure. The current I flowing through 10 ohm resistor is, so I need to find what is this current. Okay, so again here there is two voltage sources, 3 volt and 3 volt here. How to find the current here? So what I will do, I will use the superposition again. Okay, so I will take the source 1. So this is the ground and 3 volt. Okay, 1 ohm, 2 ohm. I have resistor here 10 ohm, sorry, and okay, so here I am shorting this. Yeah, so here there is no mention of this ground here, right? So what happens, this is like an open node. Okay, so current will flow from, in this source, current will flow from this node, okay, back to the ground. Okay, while there is no ground connection here, so the current through this network will be 0 ampere, while this current will be equal to 3 by 3, that is 1 ampere. Okay, so what is this current? Say I will call it as I1 due to S1, that is equal to 0 ampere. Okay, similarly the next source S2, that is next 3 volt. So here there is resistor. Here also this has to be short circuited and this is connected to ground. So here also this 3 volt, this is 1 ohm, this is 2 ohm, this is 10 ohm. Okay, so here also if you see, it is not mentioned that this ground which is the reference voltage or reference node of this source is same as this, right? So again the current will flow like this, there won't be any current like this, right? So the current I here also, so I'll call it as I2, this is also equal to 0 ampere. So I total current I is I1 minus I2 is equal to 0 ampere. So answer is B. Now this is a question, again a question from GATE 2022. The question is, for the circuit shown the locus of the impedance Z of j omega is plotted as omega increases from 0 to infinity, that is shown here. The values of R1 and R2 are, so for the circuit what is the value of R1 and R2 such a way that the locus Z of j omega is plotted as shown here. Okay, so from here it is clear that at omega equal to 0 the imaginary of z is 0 while real of z is 5, and imaginary of z is equal to 0 again at omega equal to infinity while real of z is equal to 2. Okay, so what we will do is, like, first we will find what is z of j omega from this circuit. So here R1 is in series with this parallel circuit where R2 and C is in parallel, right? So impedance of C is 1 by j omega C. Okay, so what is the Z of j omega? Z of j omega is R1 is in series, so R1 plus R2 parallel 1 by j omega C. Okay, so this is equal to R1 plus R2 into 1 by j omega C by R2 plus 1 by j omega C is equal to R1 plus R2 by, so 1 by j omega C I can take to denominator, so j omega C into R2 plus 1. Okay, so to make it as a real and imaginary term, what I will do, I will just multiply this second term with 1 minus j omega C R2. Okay, that is conjugate of denominator, 1 minus j omega C R2. I will multiply both numerator and denominator by this. Okay, so this will be equal to R1 plus R2 minus j omega C R2 square. So I took R2 into the numerator by this term into this term, so it is like a plus b into a minus b, so a square minus b square. So I can write as 1 minus j omega C R2 square. Okay, so this is equal to R1 plus R2 minus j omega C R2 square by 1 plus, because j square is minus 1, omega square C R2 square. Okay, C square R2 square. So here if you see, I can split this into real and imaginary terms, right? So what is real term? R1 plus R2 by 1 plus omega square C square R2 square. This is the real term minus j omega C R2 square by 1 plus omega square C square R2 square. This is the imaginary term. So this is real of Z, okay, minus this is the imaginary of Z. So we know at omega equal to 0 and omega equal to infinity, imaginary of Z is equal to 0, while at omega equal to 0 real of Z is equal to 5, right? So this is equal to 5. So real of Z is R1 plus R2 by 1 plus omega is 0, right? So 0 into that term, Okay, this is equal to 5, or R1 plus R2 is equal to 5. That is actually 5 kilo. Okay, so if you see here, it is in kilo ohm. So this is equation 1, and at omega equal to infinity, real of z is equal to 2k, right? So substituting omega equal to infinity in the equation, R1 plus R2 by 1 plus infinity equal to 2k. So R2 by 1 plus infinity, that is R2 by infinity, that is 0, right? So R1 plus 0 equal to 2k, which implies R1 is equal to 2k. Okay, so substituting this R1 in equation 1, I will get R2 equal to 5k minus R1, that is 2k, or is equal to 3k. So answer is R1 equal to 2k and R2 is equal to 3k. So answer is A.